Have you ever wondered about the dancing lights that paint our night sky with their vibrant colors during the polar nights known as the Aurora Borealis and Aurora Australis? These ethereal displays, exclusive to the polar regions, are more than just a feast for the eyes. They're a celestial ballet, a cosmic spectacle, a waltz of light and color that leaves spectators in awe. But beyond their captivating beauty lies a world of science waiting to be explored. Now, what if I told you there's a fascinating science behind these natural light shows? The science of these captivating lights begins with our very own star, the sun. The sun, in its unending cosmic furnace, is constantly emitting what we call solar winds. Now, don't let the name fool you. These aren't winds like the ones rustling leaves on a cool autumn day. These are streams of charged particles, a mix of electrons and protons, released from the upper atmosphere of the sun. These particles are flung out into space at mind-boggling speeds, sometimes reaching up to 1,000,000 miles per hour. And some of these particles on their cosmic journey make their way towards our home, the Earth. As these charged particles approach Earth, they encounter something quite remarkable: Earth's magnetic field. This invisible shield, generated deep within the core of our planet, stretches out into space, acting as a cosmic guardian, protecting us from the full brunt of the solar wind. When the charged particles from the sun meet Earth's magnetic field, they are funneled towards the poles, creating a spectacle of light in the process. The interaction between these particles and the magnetic field excites atoms in our planet's atmosphere. This excitement, in the most literal sense, causes these atoms to emit light. The type of light emitted depends on the type of atom being excited. Oxygen atoms, for example, give off a green or red light, while nitrogen atoms produce blue or purple light. And it's this combination of lights that creates the stunning visual display we know as the auroras, with the Aurora Borealis in the north and the Aurora Australis in the south. So in essence, these mesmerizing lights are a direct result of the cosmic dance between the Earth and the sun. A dance of charged particles and magnetic fields, of atomic excitement and light. A dance that illuminates our night sky with a spectacle of colors, reminding us of the dynamic relationship that our planet shares with its blazing star. The Earth's magnetic field plays a crucial role in this spectacle. This invisible force field, generated by molten iron swirling deep within our planet's outer core, acts like a cosmic shield. It protects us from solar wind, a stream of charged particles that constantly bombards our planet, carrying with it harmful solar radiation. Now, imagine this magnetic field as a giant funnel. As these charged particles from the solar wind approach Earth, they're deflected by our magnetic field. But at the poles, the field lines converge, providing a path for these particles to follow. This is why the auroras occur primarily in the polar regions. These particles, guided by the magnetic field, collide with oxygen and nitrogen in our atmosphere. Each collision results in a tiny burst of light, and collectively these bursts create the stunning auroras we see dancing across the sky. So, without our magnetic field, not only would we be exposed to harmful solar radiation, but we would also miss out on this breathtaking light show. To summarize, the science behind the auroras is a fascinating interplay of solar physics and Earth's magnetism. This cosmic dance begins with the sun, our very own star, which is constantly emitting a stream of charged particles known as the solar wind. This wind is a bit like the sun's breath, a continuous outpouring of energy into the solar system. Now let's bring Earth into the picture. Our planet is encased in a magnetic field, a protective bubble that shields us from the full force of the solar wind. But the field isn't perfect. At the poles, it's weaker, and some of the solar wind's charged particles can sneak through. And here's where the magic happens. As these particles slip through the magnetic field and collide with gases in our atmosphere, they get excited, and when they calm down, they release energy in the form of light. This light is what we see as the auroras, those breathtaking curtains of color that dance across the night sky. You might be wondering why the lights are usually green. That's because the most common gas in our atmosphere, nitrogen, gives off a green light when it's excited, but under the right conditions, you might see red, yellow, blue, or even purple lights. So the next time you see the auroras, remember, you're witnessing a celestial ballet of solar particles and Earth's magnetic field.